We often hear about the binary system, especially when talking about computers and digital technology. But what exactly is binary, and why is it so important? In this video, we'll break down the basics of binary, the powerful language of zeros and ones. We'll explain how it works, why it's used, and give you some examples to help you understand its impact on the tech world. Let's explore and demystify the binary system together. Binary is a simple yet incredibly powerful number system that uses only two digits, 0 and 1. Unlike the decimal system we use in everyday life, which is based on 10 digits, 0 to 9, binary is base 2. This means every binary number is composed of only two possible values. For us humans, it may be difficult to read and understand, but not for machines. In fact, binary simplifies a lot of things with which we would have struggled with our decimal system. Imagine trying to design a computer using the decimal system. Each electronic component would need to handle 10 different states, representing the digits 0 through 9. This complexity would make the hardware more intricate, error-prone, and expensive to produce. In contrast, the binary system simplifies everything. By using only two states, each component, such as a transistor, only needs to be on or off. This simplicity makes the design and manufacturing of computer hardware more efficient and reliable. Another area where binary shines is data storage. Digital devices store and process vast amounts of information. With binary, each bit can represent two distinct states, allowing for compact and efficient data encoding. Storing the same data in decimal would require more complex circuits and more space. Moreover, binary arithmetic is simpler for computers to handle. Operations like addition, subtraction, and multiplication are more straightforward in binary, leading to faster processing speeds. Decimal arithmetic, with its 10 possible states per digit, would slow down calculations. Now let's see examples of numbers in binary. 0 and 1 are, as expected, written the same as in the decimal system. Now when we get to 2 in decimal, we have to add another digit because we have no symbol for it in the binary system. So that would be 1, 0. Next number would be 1, 1, which is equal to 3 in decimal and so on. With each digit we add, we get twice as many numbers to write. That is because binary is base 2, which means that each digit corresponds to a certain power of 2. The sum of all those powers is our original number in the decimal system. Let's see that on an example. Suppose we have the number 1, 1, 0, 1, 0, 0, 1. We can write powers of 2 under each digit starting from the right. If we multiply each digit with its corresponding power of 2 and add them all up, we get our number in the decimal system. So we would write 1 times 2 to the power of 0, plus 0 times 2 to the power of 1, and we would repeat this process until we reach the last digit in our number. If we simplify, we get 1 plus 8 plus 32 plus 64. The sum of those numbers equals to 105. So the number 11010001 in binary corresponds to 105 in decimal. We can see that for writing the same number in binary, we need more digits. Computers utilize transistors that naturally represent binary states as on or off. The hardware is specifically designed to handle large binary numbers efficiently, ensuring quick and accurate computations. Thus, the simplicity of binary operations leads to faster and more efficient computing, far outweighing the drawback of having more digits. Now lastly, let's see the impact of the binary on the tech world. Binary code is at the heart of every digital device. From the simplest calculator to the most powerful supercomputer. It's what enables us to create software, develop apps, and connect with each other in the digital age. Its influence, however, doesn't stop there. It's also the foundation of computer programming languages, such as Python, Java, and C++. These languages allow developers to write instructions that computers can understand, ultimately giving rise to the software applications we use every day. Moreover, binary code is crucial for modern technologies like artificial intelligence, blockchain, and quantum computing. These cutting-edge fields rely on the fundamental principles of binary code to push the boundaries of what's possible in the digital realm. So, whether you're browsing the web, playing video games, or streaming your favorite shows, remember that it's all made possible by the power of binary code. It's truly remarkable how something so simple yet so profound has shaped the tech world as we know it. That wraps up our journey through the world of the binary system.